Alright, welcome back to episode 2. We're going to look at operations on sets, but before then I just feel like we should have a lot more examples on sets, right? So maybe one or two and then we move on. So assuming I have root of 50 and I want to simplify this, right? I know 50 is not a perfect square because there's no number that will multiply itself to give me 50. So what do? I ask myself, can I get a perfect square from 50? Yes, that sounds possible, right? And that perfect square is what? 25. 25 times what will give me 50 is times 2. And we know that this will give us what? Root of 25 times root of 2. What is root of 25? It means what number multiplies itself to give me 25? That's 5 times what? Root of 2. And this gives me what? 5 root 2. Alright, now let's look at how we can perform special operations on sets. So addition and subtraction of sets. Alright, assuming I have root of 18 and I'm adding to root of 50, right? So we saw earlier on, I just want to make it simple. We saw earlier on that root of 18 is giving us what? 3 root 2. That is what we've done here. We've seen that one. Root of 18 is giving us 3 root 2, right? Plus what? Root of 50 is what? It gives us 5 root 2. Now there's this thing about sets, right? Just like when you are adding in normal algebra, you want to make sure that you have like terms, right? And for sets, the like terms is what? The number under the square root. Is that fine? So we have root of 2 here, we have root of 2 here. So it makes this what? Like term. So I can comfortably add what? Their coefficients. And so this gives me what? 3 plus 5, that gives me 8 root of 2. So I'm done with that addition. Right? That's cool, isn't it? Let's take the same thing and try to do the subtraction of it. Okay, in fact, let me take another example. Let's say root of 27 minus say root of 12. Okay, root of 12. So we first of all have to ask ourselves, is this a perfect square? Are these perfect squares? Can we find the square root of that easily? We cannot, right? So we've asked ourselves, can we get a perfect square from 27? Yes, of course. That's 9. 9 times what gives me 27? 3. And then minus root of 12. Can we get a perfect square? Yeah, that's what? 4 times what gives me that 12? That's 3, right? And I know if I have something like this, I know I'm going to get the square root of 9 to be 3, and the square root of 3 still remains root 3, right? Then minus, this is what? Square root of 4 gives me 2, then root of what? 3. Square root of 3 is still root of 3 because 3 is not a perfect square. Okay, so now I know I have like terms, right? So root of 3, root of 3. So I can comfortably subtract them. So I'm going to subtract the coefficient. So I get 3 minus 2, that's 1. 1 root 3, which is simply root 3. Right. So that's the basically starting off with what? Addition and subtraction of sets. In our next examples, in the next episode, we're going to look at how to multiply sets and divide, and then also add and subtract sets that are in the rational form. See you.